Hydropower, energy that is derived from the flow of water, could be considered to be one of the oldest forms of energy utilized by the human race. We've seen it in water wheels that kept the old water mills running to the more modern hydroelectric dams of today, like what we've seen here in St. Cloud. While its true origins can be traced to any one place or person, modern development of hydropower here in the United States was helped along by a man called Lester Allen Pelton, inventor of the Pelton water wheel. For its time, the Pelton wheel was the most efficient water turbine. Its design made it so that water left the wheel with very little speed, in the process extracting as much energy as possible from it. Today, hydropower is generated mostly through the usage of hydroelectric dams. According to the United States Geological Survey, hydroelectric power accounts for at least 7% of our nation's total energy production. This energy is produced when water flows through the dam and spins the turbine blades within, which in turn are connected to power generators that use the energy from the flowing water to generate electricity. So, what exactly is going on as energy is being generated?
The following pictures are from the St. Cloud Hydropower Dam. Looking at this picture, you can see the outflow of the dam. The outflow is released by the control gate. Outflow is the water from the dam after passing through the turbine. The force of water from the reservoir pushes against the turbine blades and converts the kinetic energy of falling water into mechanical energy. The collected energy is then converted from mechanical energy to electrical energy using a generator that is attached to the turbine.
B-roll. In our experiment, we used the continuity principle to calculate the amount of water that runs through a pipe through our dam. To calculate the flow rate, it is velocity times area, and to calculate the velocity, it is the square root of 2gh, where g, the gravity, is 32.2, and h is the height of our pipe. All our measurements were in feet, so the velocity of our pipe was the square root of 64.4 times 0.08 feet, which equals 2.3 feet per second. The area is calculated by pi r squared, which comes out to pi times 0.04 squared, which equals 0.005 feet squared, which the area and velocity calculated, we can figure out the flow rate coming out of 2.3 times 0.005 equals 0.012 feet cubed. And our flow in equaled flow out, which showed us that we had a steady flow.
Hydropower is the most important and widely used renewable source of energy. China is the largest producer of hydroelectricity in the world, followed by Canada, Brazil, and the United States. Hydropower represents about 16% of the total electricity production. Some pros of hydroelectric power are its low failure rates and operating costs, and they are extremely efficient. They are also a clean fuel source and are rapidly available due to rainfall and snow. Some cons of hydroelectric power is that they are extremely expensive to build and have a high hazard risk. Also, they cause low oxygen levels in water.
It's gonna flood! They need to start dumping more water right now. It's still flooding.
I just spoke to Hoover Dam's operations, said that they're releasing the overflow at full capacity.
Jordan, they can't dump it any faster.
Issue an evacuation warning to all the areas along the lower Colorado. I don't know if the dam can hold up much longer. I'm gonna go check it out. It's like Niagara Falls out there.
Jordan, there's nothing more you can do. Get out of there! Jordan, get out!